A comet from another star system just pulsed. Not with light, but with magnetism every 147 seconds. A perfect signal. Michio Kaku says this shouldn't exist. Comets aren't supposed to do this. Nothing in physics explains it. What is 3AI Atlas, and why is it breaking the rules of reality? Kaku's warning, a pulse from the void. This magnetic pulse breaks known physical law. That's how Michio Kaku described the signal from 3AI Atlas, a comet-like object that just did something no known celestial body should be capable of in the vacuum of space. Silence is expected, especially from interstellar objects, which typically drift past without a sound, releasing gas and dust only as they near the sun. But this one was different. It spoke not in light but in magnetism. Every 147 seconds, 3AI Atlas emitted a precise magnetic pulse so consistent that it echoed across Earth's magnetometers and space-based sensors alike. No known natural object pulses like that. Not comets, not asteroids, not even the most chaotic tumbling ice balls from our own Oort cloud. To Michio Kaku, this wasn't just an anomaly. It was a signal that physics itself had been challenged. He has long argued that breakthroughs begin where models fail. Just as quantum tunneling was once seen as impossible, particles appearing where they physically shouldn't, this pulse could be our generation's equivalent moment. A wake-up call that the universe still holds secrets far beyond the edges of current theory. But Kaku also knows the weight of caution. Nature doesn't just break its own laws for no reason. If something behaves in a way we've never seen, it means one of two things. Either there is a hidden mechanism we haven't discovered, or the foundation of our understanding is incomplete. This isn't just about one object. To Kaku, this is a philosophical tremor, a reminder that even now in the 21st century, we are still students of the cosmos, and the lesson has just begun. If you're fascinated by these mysteries, make sure to subscribe so you don't miss the next deep dive into discoveries reshaping our understanding of the universe. The interstellar visitor that shouldn't speak wasn't just another rock drifting through space. It was fast, too fast. On July 1st, 2025, it appeared as a faint streak in data from the Atlas survey in Hawaii, but its trajectory and speed were off the charts, over 26 km/s. Even after correcting for the sun's gravity, that meant only one thing. This object came from beyond the solar system. Astronomers quickly confirmed its hyperbolic orbit with an eccentricity far beyond anything bound to the sun. It wouldn't loop back. This was a one-way visitor, cutting across our system on a permanent escape path. Designated 3AI Atlas, the third confirmed interstellar object in history, it immediately became the subject of global focus. But even early observations hinted it wasn't behaving like the others. Michio Kaku calls such objects test particles of the galaxy, natural messengers from systems we'll never visit, bringing with them the untouched chemistry and physics of alien stars. In his view, these bodies are like lab samples sent to us by the universe itself. But 3AI Atlas wasn't passive. It wasn't silent. It emitted heat in rhythmic pulses. It vented carbon dioxide in staggering quantities. And later, it unleashed that now infamous magnetic signal, echoing like a cosmic metronome. These weren't random outbursts. They were structured, precise, and most of all, unexplained. Kaku sees this not as a curiosity, but as an invitation. If this object is pulsing, venting, and radiating in ways we've never seen, then maybe it's telling us something. Not intentionally, but through its very nature. Something about the deep space it came from. Something about what's possible when matter forms under alien skies. And the first piece of that message lies in its chemistry. The composition so extreme even our weirdest comets can't compare. AI Atlas isn't just strange because it's from another star system. It's strange because it's made of the wrong stuff. Most comets, even the oddballs from the Oort cloud, release a mix of water vapor, methane, and small amounts of carbon compounds. But this object didn't follow that formula. Over 90% of its outgassing was pure carbon dioxide, not mixed, not diluted, just CO2 pouring out in a steady, uninterrupted stream. To Michio Kaku, this was the first chemical alarm bell. No comet we've ever studied behaves this way. It suggests that 3AI Atlas formed in a region of space far colder and more chemically extreme than anything near our sun. It didn't just carry exotic material, it was exotic material. The James Webb Space Telescope confirmed it. Thermal scans showed a consistent release of heat, but not chaotic, not random. The temperature rose and fell with mathematical precision, almost like the beat of a machine. That pattern repeated again and again, mirroring the same interval as the magnetic pulse that would be detected later. Kaku interpreted this as something deeper than coincidence. The CO2 wasn't just escaping, it was being vented with intention, or at least with a mechanism we don't yet understand. He described it as a kind of chemical signature from another world, possibly even another kind of chemistry altogether. Something shaped by conditions that Earth-based science has never been able to simulate. The mystery grew because if an object is venting pure carbon dioxide like a heartbeat, and at the same time releasing heat and magnetism, then we're not just dealing with an icy body anymore. We're dealing with a phenomenon. And for Kaku, that meant one thing: time to rewrite what we think is possible. The first detection of the pulse came from a magnetometer in Utah, a small spike that repeated every 147 seconds. Not approximately. Exactly, it wasn't interference or solar activity. It was a precise rhythmic magnetic pulse, and all data pointed to 3AI Atlas. Soon, stations worldwide confirmed it. Japan, South Africa, Alaska, even satellites far from Earth picked it up. The pulse wasn't local. It was coming from deep space, and it was coming from this object. Michio Kaku recognized the implications immediately. Natural objects don't emit timed magnetic signals, especially not comets, and not with this kind of precision. It defied every known model. Scientists tried to explain it. Could it have a magnetic core? Spectral data said no. No metals, just ice and carbon dioxide. Could it be spinning like a dynamo? Its rotation didn't match the pulse. Plasma, solar wind? Too chaotic. Nothing fit. So what was left? Kaku's answer: nothing in current physics explains this. Gravity, magnetism, thermodynamics all fall short. And yet the signal is real, constant, predictable. This isn't just rare, Kaku said. It's forbidden. And contradictions in physics are how revolutions begin. After the pulse was confirmed, researchers rushed to explain it using known physics. They started with the obvious, a metallic core. Maybe it had enough iron to retain magnetism from long ago. But the scans showed no such materials. Just ice, dust, and carbon dioxide, not magnetic stuff. Next came rotation. Could it be spinning fast enough to create a magnetic field? The light curve said otherwise. It wasn't rotating fast. And worse, the spin didn't match the 147-second pulse. Not even close. Plasma effects were modeled. Dust grains, solar wind, charging effects, but plasma is messy. It surges, it flickers, it doesn't tick like a clock. Models showed only irregular, unstable signals. Nothing like what they observed. Every natural explanation failed. The pulse was still there, stable, unchanged, unmatched by any comet or asteroid. No mechanism could explain it. And that, Kaku says, is the breaking point. When you run out of options, you're forced to admit the truth. The models are incomplete. Something's missing in how we understand interstellar objects. And that's when Kaku looked backward to the other puzzles we never solved. AI Atlas isn't the first time the universe broke its own script. In 2017, Oumuamua entered our solar system and accelerated with no visible propulsion. It had no tail, no venting, and yet it sped up. Scientists tried to explain it, but nothing truly fit. Then there's the 1977 WOW signal, a 72-second radio burst at 1420 MHz, detected once, never repeated, never explained. It became one of SETI's most enduring mysteries. Kaku doesn't see these as isolated. They're part of a pattern, events that step outside the laws we expect. Signals, pulses, unexplained forces, moments where randomness gives way to precision. He calls it a statistical fingerprint, a subtle trail that suggests something deeper. Maybe these are rare natural events. Or maybe we're brushing against something more. Kaku compares it to Mercury's orbit. That tiny deviation led to Einstein's theory of relativity. Perhaps now it's happening again, but with magnetism. Each anomaly is a crack in the surface. And with 3AI Atlas, that crack just got wider. When nothing familiar explains an event, Michio Kaku looks to the frontier. One idea is that 3AI Atlas contains exotic ices. Not the water and CO2 we know, but materials stable only in deep space. Under extreme conditions, they might switch states and release energy on a fixed schedule. Experiments on Earth have hinted at this. Compressed or supercooled ices can create small electric or magnetic effects. They're tiny here, but scaled to an object kilometers wide in space, they could become significant, enough to generate detectable magnetic pulses. Kaku calls this dark chemistry, not science fiction but unexplored physics. If true, the object isn't a probe. It's a messenger from an environment we've never studied directly. Still, there's a problem. The 147-second pulse doesn't drift. It doesn't change. It stays locked with the object's thermal and gas patterns.